One last topic that we need to cover before we finish up lesson 4.2 is the idea of Simpson's paradox. This is a situation that comes up when you're looking at a marginal distribution of two categorical variables where you get a result that's not quite what you might expect to see from the data. And the reason that Simpson's paradox exists is because just as with quantitative variables, categorical variables can also be affected by lurking variables. So if you ever are looking at a two-way table and some of the data seems to be maybe a little skewed or maybe just doesn't seem to be presenting itself the way you might expect or in a logical fashion, something like that, you might be dealing with a situation that involves Simpson's paradox. So let's take a look at an example. So we've got this table, it's a two-way table of course, and it lists the number of successful sales calls for two employees over a 2-week period. Our employees are Lisa and Bart, in honor of the Simpsons. So it looks like in week 1, Lisa had a 60% success rate with her sales calls, and she achieved sales for 60 out of 100 attempts. And in week 2, she achieved success in 1 out of 10 of her sales calls. So of course in week 2, she was successful 10% of the time. Bart, however, looks like the number of attempts was flipped for them from week 1 and week 2. He only attempted 10 sales calls in week 1, was successful 90% of the time in week 1, and then in week 2 he did attempt 100 sales calls and was successful 30% or 30 times. So he was successful 30% of the time. Now what we need to do before we get much further here is we need to take a look at what their overall success rate would be. And you've probably already noticed that this table is actually a combination of both the marginal and the the marginal and the conditional distributions for our categorical variables, because we're taking a look at both the counts and the percentages for our variables. So let's fill in this total column. We know that Lisa was successful with 60 calls in week 1 and 1 call in week 2. So that, of course, means that she had a total number of 61 successes out of, that's supposed to be a 61, which you can't read. Let's try that again. It's a little better. So she was successful 61 out of 110 attempts, and Bart was successful 39 out of 110 attempts. So let's get their percentage success rate. 61 out of 110 is 55.5%, and 39 out of 110 is 35.5%. So I didn't even put that for just a second. 55.5 and 35.5. So let's take a look at this. We've definitely done the math correctly. The sums add up as we expect, and we've calculated the percentages appropriately. But take a look at what we see here when we compare the percentages. In week 1, Lisa went on more sales calls, but she overall was not as successful as Bart was. She was only successful 60% of the time, whereas Bart was successful 90% of the time. And in week 2, same thing. Even though she went on 10 sales calls, she was only successful 10% of the time, where Bart was successful 30% of the time. So in both weeks, overall, when you look at the percentages, Bart was more successful. He had 90% compared to Lisa's 60% in week 1, and he had 30% compared to Lisa's 10% in week 2. However, when we look at our total percentages for the 2 weeks combined, it tells a different story. Here it looks like Lisa was more successful overall, because her overall percentage is 55.5%, whereas Bart's overall percentage is 35.5%. So this is an example of Simpson's paradox. Again, it's because when we look at the two categories individually, it looks like overall Bart should be doing better. He performs better percentage-wise in week 1 and in week 2. But even though his performance in both weeks is better, when we look at the total performance over the 2 weeks, it ends up looking like Lisa's percent is better. Now, how does that occur? Well, it turns out that that's happening because of the relatively large disparity in the counts, or the number of attempts in each week. Lisa attempted 100 sales calls in week 1, whereas Bart only attempted 10. And then the situation is flipped in week 2. Lisa attempts 10 and Bart attempts 100. So that when we take the total, Lisa's 60% performance gets quite a bit of weight because that was out of 100 people, whereas Bart's 90% performance gets very little weight because that was only out of 10 people. And so again, this is an example of Simpson's paradox, which I'll state specifically. It's simply an association or comparison that holds for all of several groups, and that association or comparison can reverse directions when the data are combined to form a single group. So again, that's exactly what we have here in our example. That association that said that Bart performed better in both weeks individually, that was flipped when we looked at the total data, and it looks like Lisa's performance was better, even though that's really not what was happening if we're looking at this data on a percentage basis.